before we jump into the hyperbola and you don't like each other, it's okay. The hyperbola doesn't like many people, so you have good company. Before we jump into the lesson, we're just going to do the same thing we've done for all of the lessons during this holiday period. We may have run out by now because we've had one in each lesson, but if anyone has a tricky question from your test or your exams that you have recently done that you would like us to go through together, or you didn't understand, or you didn't understand the memo, or it's just been bugging you, this is your time to ask. So just pop your hand up for us and we can go over whatever you would like us to go over. So if you have a question, just pop your hand up and we can go through it. Oh, Nati, you're currently writing exams. That's useful. If you have a question that you are studying that you don't understand, you're also welcome to throw it our way. It just obviously can't be one of the like picture questions, but yeah. If it's one of the algebraic ones, yeah. Okay, do we have no questions for tonight? Simultaneous equations. And eventually, great. Chuck that hand up and then I'll unmute you. Cool.
Ma'am, the question was, it said determine the equation of the asymptote.
Okay.
And I think it was gx equals -2 over x, and then on the side -2.
-2.
Yes, ma'am.
Okay, cool. Thank you. We can definitely talk about this one. Okay, so let's chat about this one together, guys. If we saw this equation, first of all, what type of graph is this? Who can tell me what type of graph this is? Is it a straight line? Is it a parabola? Let me write your options here. Is it a straight line, parabola? Oh, I didn't even need to write all my options. You guys are too brainy. Yes, it is 100% a hyperbola. Yes, good. Okay, good. So a hyperbola means that we're going to have two asymptotes. Okay, so think about it like this. When we have a let me actually just draw this a little bit bigger. When we have a hyperbola, there's a few, gross. There's a few things here which are really helpful. And I'm just going to kind of sketch this. So if they ask me to do this in an exam, we don't have to do it super neatly because they're wanting the equations of the asymptotes. They don't care about how neat it is. This is all just us working things out. Okay. First of all, our A value is negative, which means that it's going to be in quadrant 2 and quadrant 4. Okay, so we know it's going to be in this quadrant and in this quadrant over here. This is telling me my shift down. That is telling me my vertical shift. But in hyperbolas, it is also telling me one of my asymptotes. Okay, so it's telling me that I have an asymptote that is chilling down here at y is equal to -2. So I'm going to have an arm that looks like that. And I'm going to have an arm that looks like that. And then I've got that asymptote at y is equal to -2. But a hyperbola has got two asymptotes. That is one of my asymptotes. What is my second asymptote in this picture? And it's always the same for a hyperbola in grade 10. Yes, guys. Yes. X is equal to 0. So those would be my equations of my asymptotes for that function. And to make clear, does that answer what you were wanting?
Yes, ma'am. Thank you.
Awesome. Great. Oh, guys, my power just came back on. How exciting. Okay, so we knew it was a hyperbola because the x was at the bottom of my fraction. So just as a little sort of helping guide to our different equations, we have y equals mx plus c. That's our straight line. So we just have a single x for a straight line. Then we have y is equal to ax squared plus q. So we've got an x squared. That's going to be our parabola. So that's our parabola. That's our straight line. If we have y is equal to a over x plus q, that's our hyperbola. So that means it's at the bottom. If we have y is equal to a to the power of x plus q, that's talking about our exponential. So those are our different ways of knowing. If it's a single x, it's straight line. If it's x squared, it's a parabola. If it's over x, it's a hyperbola. If it's to the power of x, it's an exponential. Oh, you never did hyperbolas. Oh goodness, this must look terrifying to you right now. I'm sure you will be covering them in the upcoming term then. Cool, 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 cool. Okay, let's jump into a question. So now the first question I've put for tonight is not too scary. I've tried to make it doable. So there's a lot of things that I want you to try and be able to do with yourself. And then the second question is quite a little bit trickier. So there's more things that we're going to sort of talk about together. But the first one, I think there's more things that you'll be able to do alone. Yeah, Nazarene, ask away. That's what I'm here for. If you want to ask it out loud, you just need to use the hands up emoji so that I can unmute you. There we go. Hi, sweetheart. How can I help?
I just know, does my asymptote represent my new x-axis now?
Yes, exactly. So when our hyperbola shifts up or down, it creates new quadrants. And so it's basically like our new x-axis.
Okay, thank you.
You're always welcome. Kaviso, how can I help? I can see you. Oh, there we are. Hello.
Ma'am.
Yeah, I can hear you.
I also have a question.
Ask away.
Yeah. Can you write down with? No, it's my own question from the test.
Okay, so you have a different question.
Ma'am, are you writing down?
I'm struggling to hear you because you're breaking up a bit, but I'm trying.
Yes.
Okay, so Kagiso, I think, Aviso has a question from her exam and not what we are doing.
Yolanda, do you mind trying to send her a direct message and seeing if you can get it in a text for us and then just sending that through to me?
Okay, that's perfect. I can do that.
Thank you. Mokokobale?
Hello, ma'am.
Hi.
How are you?
I'm good as always.
I'm good, ma'am. I have a question. It's similar to the one that I asked the other day.
Okay.
I just found in my paper also. So, ma'am, it's x to the power 3 plus 3x squared plus 3x plus 1 over x to the power 3 plus 2x plus x.
Plus x.
Yes, ma'am.
Okay, and then did they say simplify?
Yes, they said we must simplify.
Okay, so if we had to simplify this one, we would have to factorize. So our first thing that we'd have to do here is we would need to see what we would be able to join. So let's try and do grouping and let's join those two together and let's see if it works.
Okay.
I don't think it will though. If I take x squared, I'd be left with x plus 3. No, that's not going to work. Okay, so we can't group it that way. So let's group it. I wonder if that way would work. Then I'd have, no, let's group those two and no, that doesn't work. Okay, 3x squared, if we took out, this question's gross, Mokubale. Why do you always give me these gross questions? I mean, I like it that you give me.
Ma'am, if it's gross for you, what about us?
No, I appreciate that you give me these gross questions, but they are gross. I need to say that they're gross so that we're all on the same page. But I do feel bad for you if you were seeing this for the first time.
Ma'am, it was very hectic.
It is hectic. I think let's start with what our denominator would look like. So if we took out x as a highest common factor, we would be left with x squared plus 2x plus 1. So we probably would want something that looks something like that. And we would be able to do that. How could we do that? Oh my goodness. You know what I might have to do, Mokwale? I think I might need to sit with this one and think with it properly so that I don't waste everyone's time. So do you mind if I just keep this one and then we do it first thing on Thursday?
No problem, ma'am.
Thank you. I'm just trying to think how they want us to do the grouping in the numerator where it makes sense, and I don't want to take time from everyone. But I promise we'll do it first thing on Thursday.
No problem, ma'am.
Thank you, my sweetheart. Always trust Mokukubale to give my brain a stretch at the end of a long day. I appreciate it, though. I do appreciate it. Okay, it's going to bug me for the rest of the night, but it's fine. Let's move along. Let's try and have a look at this question over here. So what we are looking at is we have got a parabola, which is our blue graph, which is, I'm going to highlight over here for you so that you can see what's going on. That is our parabola. And then we have got a red line, which is the y equals 7. So it's a little bit different. It's not like a y equals mx plus c situation. It's just a straight line. So first question here is calculate the distance of BC. So this is B and that is C. Can someone give me a suggestion on how we would calculate the distance of BC? Can someone give me a suggestion? You don't have to tell me the whole thing. You don't have to get into the maths of it, but tell me what you can notice that would be helpful, that we could do. In the bank, Claire, we're all yours.
Ma'am, I think you could substitute to find the x-intercept, and that will tell you where it is. And
Yes.
then it'll be equal on both sides. So then you just add.
100%. Beautiful. Okay, so these are our x-intercepts of our parabola. Okay, so if we find our x-intercept of our parabola, we'll be able to find that distance. Okay, there is no asymptote here. So it's a very normal mistake to see that when we have a line like that, we think it's an asymptote. We only have asymptotes in exponential graphs and hyperbolas. We don't have asymptotes in parabolas. That line is just a straight line that's been drawn for us. So I want you to figure out what my distance for BC is and let me know once you have an answer.
Let's do this, guys. Remember, you're allowed to take a screenshot of this question just in case if something happens. Take the screenshot.
Sarah, you put those white flags away. You do not need them right now.
Banning, no, the white flags.
Goodness gracious. No need for those white flags. Oh, we've got our energetic one. We're ready. Bokamoso, hello.
Hello, ma'am. Hello, people. How are you doing today?
Very well, thank you. How are you?
I'm good. Okay, so for this question, okay, I'm not sure if I am right or not, but according to what I was seeing, it was fiscal fund. So I got and first brackets in bracket was x minus 4. Then I had was a equals to x to the power. So you're actually gonna do about that minus in front of, I'm down here.
Is it me or Bukamoso's network is glitching?
Hello.
Hi, Bukamoso. Okay, so I'm here, Bukamoso. So what? I think teacher will come back now. I couldn't hear your question. It was glitching when you were asking the question. What did you say your question was?
Oh, what I said was that I got fiscal van vierkante, meaning it was x plus 2. I got two brackets actually. The first bracket was x plus 4, x plus 4, and then the second one was x minus 4. But then I am a little bit concerned about what I wrote here. I'm not quite sure actually about what I wrote because of the negative, that minus in front of the x, that minus, the negative sign in front of the x.
Yeah, so I mean that's just there to sort of throw everyone out. But teacher Jenny is here to explain that part. So teacher Jenny, to just fill you in, Bukomoso got in brackets x minus 4 and the other side x plus 4, but she wasn't really confident because of the minus sign in front of the x. That's what you missed.
Okay, thanks, Fukamoso. Sorry, I think your energy got my computer overexcited and it kicked me out of Zoom.
Lol.
But okay, so I'm actually glad that you were worried about that because that's a normal thing to worry about. When we see that minus, we think we're not allowed to factorize it. We don't know how to factorize. Oh, can anyone else not hear me?
No, I can hear teacher Jenny nicely, Bukomoso, can you hear me?
I'm going to write so long while that sorts out. So I think by the sounds of it, we're definitely on the right track of having a substitution of 0 for our y-axis. So we're going to have 0 is equal to negative x squared plus 16 because we want our x-intercept. And at an x-intercept, that is when y would be equal to 0. Okay. And so from there, we would want to move everything so that our x squared is positive and our 16 is negative. So basically, I'm moving those to the other side. So I would have x squared minus 16 is equal to 0. Now that I've moved it, it's very easy for me to factorize. So then I could just be like x plus 4, x minus 4 is equal to 0. So then x would be equal to positive or negative 4.
Well done, Bukomoso. So your answer was correct.
Shame, Zandasile also can't hear me. So that's really weird if some people can hear me and some people can't.
So I'm just
worried.
Zandasile, can you hear me? Because I can hear teacher Jenny.
Oh, now Zandasile can hear me. Okay.
Oh, okay.
Okay, good. Okay, so then we land up with this x plus 4 and x minus 4. So then that would be 4 and that would be minus 4. And so then the next place that we make a very normal mistake is that when we see the word distance, we think, okay, we have to use the distance formula from analytical geometry. But we absolutely do not need to use it when we're in functions. We just have to use our brains, okay? We have to think this distance here would be 4 units, and this distance here would be 4 units. And so the distance between B and C is 8 units. That's all. Inabencle, hello, how can I help?
Ma'am, for the previous one, when we substituted y for 0, could I have moved the x squared only over and then square rooted both of them to get the same answer?
100%, as long as you have the plus minus in front of that square root sign.
Okay, ma'am.
Okay. Why do we move both the x? You don't have to. So you could do exactly like what Inabentle said over here. You can move your x squared over and leave your 16 on that side. The only thing with that is that I'm worried you're going to forget that you have to have the plus minus. So when you square root something, you have to remember that there's a positive or negative answer. Okay, so then my answer would be positive or negative 4. So if you are confident that you're going to remember that plus minus in front of the square root, I have absolutely no problem with you doing it that way. If you're worried you're going to forget that plus minus, then stick to factorizing. Paul, you could absolutely times everything by -1 to switch the signs. You could also take -1 out as a factor to start and then divide by -1. All of those would be fine. 100% fine. How did we feel about getting the 8 units? Ah, you got it right. Well done, Tasmin. That's awesome. Not accidentally. Give your brain some credit.
Well done, Desmia. It wasn't an accident. Don't worry.
Yeah, definitely not an accident. Nice job. Okay, so the next one is slightly trickier, but it's actually not so bad because I haven't given you a long equation. I've just given you a nice straight line. So the next one, I want you to calculate the distance of DE. So that's this distance over here. So my question to you now to sort of, Pablo, yes, well done. And my question to you now is, what is the important thing for us to notice about D and E that's going to help us? So for B and C, the important thing for us to notice was that they were x-intercepts. What's the important thing for us to notice about D and E? Good, it's going to involve y equals 7. So at those points, y is equal to 7, 100%. So at those points, y is equal to 7. There's a specific word that I'm wanting you to tell me. Not parallel, not 14 units. That's what your teacher wants you to fall into the trap of, though. Not y-intercept. Emmanuel, are you going to give me the answer I'm looking for?
Hi, ma'am.
Hi.
Ma'am, I think the answer you're looking for is that D and E are the points where the parabola and the straight line graph are equal.
Yes, beautiful. They are points of intersection.
Well done. Emmanuel.
Beautiful. Nice job. Okay, so it is a
Okay.
point of intersection. It means that that is where my parabola is equal to my straight line. Okay, so it's saying it is where this graph is equal to that graph. And that was also said when Portia said y is equal to 7, it means the same thing. I just want you to get into the idea of saying points of intersection. So if it was a more complicated equation, we'd be able to find our way. Okay, but now we know that our y value is 7. Okay, which means we can substitute, this is for B, we can substitute y is equal to 7 into y is equal to negative x squared plus 16. So I want you to give that a go. I want you to see if you can find your x values. Remember that everything will be symmetrical around your y-axis. That might help you a little bit. And let's see how this goes. So you're going to substitute the idea that y is equal to 7 into that equation. So we're subbing it in. So whenever we have a point of intersection, we're saying that they're equal to each other, right? And so in this case, we're saying that this graph is equal to this graph, which means we're saying that our y values are the same as each other. So we're saying 7 is equal to negative x squared plus 6. All we're saying is at that point, the straight line is equal to our parabola. We're saying they're the same. We're equating them. Yeah, equating, exactly. So we should get somewhere along the lines of x squared minus 9 equals 0 or x squared equals 9, depending on how you've worked yours out. So then we'll have x plus 3, x minus 3 is equal to 0. So x would be positive or negative 3.
Well, Cam was so on the line.
Hi, my love. How can I help?
Yeah, okay. So for this question, I got x is equals to minus positive, okay, plus minus 3.
Good,
Am I
that's
right?
right. Yeah, that's 100% right.
I'm getting somewhere.
Look at you dominating the functions.
Well done.
Nice job. Okay, so we now know that it's negative 3 and positive 3, which means the distance between these will be 6 units. Okay, so there's a couple things here where they like to trick us, and we're not going to fall for those tricks when we see them. So we're going to see distance and we're going to be like, no, we're not falling for that trick. We're not going to go down this whole distance formula route. We know we just need to work these out and get our answer. Okay. Last one, easiest one of this whole question. Calculate the distance of A, O. It would be helpful if I had an O. My O went missing. That's O. So I would like the distance of AO. So what do we care about for AO? What's going to help us to find AO? Yeah, exactly, Paul. It's 100% going to be 16 units. 100%. We don't have to think about anything stressful. We know that that 16 is telling us where it's crossing our y-axis. At that point, that's 0, 16. It's telling us that that is 16 units high, which means that from A all the way to O, which is 0, it's going to be 16 units. So all we cared about here was some teachers call it the turning point. They're quite sort of particular about it. Some will stress that it's the y-intercept. So any one of those words, those are the words that we would care about in this particular situation. Bokomoso, hello.
Okay, so I'm not arguing. I completely agree. It's going to be 16 units. But how did you get there? How did you get 16 units?
Okay,
How?
so we know from the parabola formula that plus 16 is telling us our y-intercept. So it's telling us this value. It's telling us A. Because it's telling us where it's crossing that y-axis. And so because we know that that's 16 and we know that 0 is at O, then that whole distance between 0 and 16 must be 16.
Oh, okay, no problem.
Okay, great, good. Fabalo, it happens all the time. You also have to remember to be kind to yourself because in test situations, our brain is not in a good state of mind. Okay, our brain in a test situation is stressed, it's trying to think about things, it's panicking. And so often we make mistakes in tests. And that's why specifically with maths, we have to do as much practice as humanly possible so that things just sort of become routine and we don't have to panic as much. But the more of these questions that you see, the less likely you'll be to make a mistake in your test or exam. Nice work. You did super, super well. Take a screenshot if you would like. We're going to go to Brian for our brain break after this. And then we're going to try a slightly juicier question.
Screenshots, your time.
So our brain break, for those of you who are new, it's just something silly or fun to get your brain out of the maths work, just to give yourself a bit of a break, and then we get back into the maths afterwards. So please don't panic if you don't understand what's going on. And for those of you who are new, if you're feeling a little bit lost and you're seeing a whole lot of things on the screen and you're feeling a bit intimidated, it's okay. All right. Remember that a lot of the people on this class have done a whole functions course with me where we spent more than a month talking about functions, and all of those videos are on the Watobe website. You can watch them, you can go at your own pace, you can pause when you need to, and then these ones will feel a lot less scary, I promise. Don't feel like a doofus, you'll be fine. Okay, so our brain break today is slightly different to what we have done before. We are doing something called a dingbat. Has anyone heard of a dingbat before? I think you'll know what a dingbat is. You might just not know that that's what its name is.
A dingbat.
A dingbat.
Yeah.
Have you, okay, so a dingbat is like when you see a picture and you have to say like the phrase that would be associated with that picture. So you have to like look at what the picture would be and think what could that picture mean in like a sentence, if that makes sense.
Oh,
so it's like a common phrase or something that you say to people. All right. So the first one is super easy, just to sort of ease you in. And then we'll see how the next one goes. There's 3. So we'll see how it goes. Okay. So this is our first one. What would be the phrase associated with this picture? Yes. Oh, no. Some of you were right, and then some of you were very wrong.
Well done, guys.
Not 4 eyes. Not 4 eyes. Not 4 eyes.
Eye for an eye. Well
but
done.
it was exactly, some of you got there. It's an eye for an eye. Okay, so it's an eye for eye. Eye for an eye. Do we see it? So just to help you, that's how these work. So you'll see something in the picture and then you've got to try and sort of put them together and think about what that would mean. It's okay if you're too late. That's all right. Okay, so this one was an eye for an eye. Let's see if anyone can get our next one. There we go. Not turn.
Has to be a common phrase, guys. That
But Mello, that's close, but it's not right. It's not torn.
I think like everyone just feels like there's a missing like letter, but is it?
It's something you would say. It's not underturn. It's not tonight. Not return. Your turn. No. T right now. Turn up. No. No U-turn. Annalisiwe. Yes. Well done.
No U-turn.
No U-turn. And the reason it's no U-turn is because there is no U in turn.
The turn.
There is no U in the turn. Okay.
That was so lame.
I know. I don't see where I got it though.
Well done. Well done, Annalisiwe. That was impressive.
Okay, let's see who can get our last one for the night. All right. Last one for tonight. No. Train, no. Gucci. Rainbow, no. Mpo! Yes! Well done! And Annalisiwe, oh goodness, you guys are really good at these. It's see you as in see you around. I'll see you around. You immediately thought of cocoa melon. What on earth is cocoa melon? That is bizarre. Well done to those of you who got it. Oh, it's a cartoon. Okay. Nice job, guys. Well done. You did well. Okay, now that our brain has sufficiently had a break and the flug's tea is the right temperature, let's do one more maths question for the night. Okay, so let's have a look. This one's spicy. Okay, the sketches show the graphs of y is equal to -6 of x. So that's our blue graph, that's our hyperbola. Okay, so y is equal to -6 of x. And then we also have y is equal to -x. That's our red line that we've got chilling. Okay, so we've got a hyperbola and we've got a straight line. All right, let's try and break this up step by step. First question, determine the coordinates of A and B. So let's have a look at that. That's A and that's B. So I want you to think of what I was asking you in the last question. And I want you to tell me what I want to know that's special about A and B. What is special about A and B? Or can you say, yes, what is special about A and B?
Hi, ma'am.
Hi.
It's the point of intersection.
Yes, beautiful. It is the point of intersection. Okay, I see we're saying inception. We're not in the movie of interception. We are intersection. Okay, so these are points of intersection, and the reason it's intersection is it's because they intersect. Okay, so intersect is where they cut each other. Beautiful. They are points of intersection. Now, a point of intersection is where one is meeting the other. So in this case, it's saying where our straight line is equal to our hyperbola. So we are equating our two equations. All right. I want you to do that. I want you to work out first your x values for A and B, and then your y values for A and B. And I want you to give me your coordinates for A and then your coordinates for B. And hopefully, next time you see something like this in an exam, we don't make mistakes. We'll be able to get it right. and we'll be little brain buffs. Good, points of intersection, great. Hello, my energy bunny, how can I help?
Oh, okay. So I don't understand. How are we gonna do this exactly? Because our y, the red line, the red long straight line is equals to minus x, and then our blue over here, it doesn't necessarily have an x in its value. I mean, doesn't have a value for the x. Yeah, that
equal to this, right?
Yeah, but then like, how exactly are we gonna do it? I'm lost.
Okay, so what we have here is we have a fraction equation. So when we have a fraction equation, we need to get a common denominator. We need to get everything to be equal to each other. So basically, this at the moment is over 1, and we want it to be over x. So we're going to multiply that by x, and we're going to multiply that by x. Does that make sense?
Thank you for giving me some light.
Okay, good.
For a second, I thought Teacher Jen wasn't with us. I was like, where is Teacher Jen?
Can you still hear me?
Yeah, we can hear you, but
I think so. Everything on my side has frozen.
Oh, I see. Like on your screen, you mean, but we can hear you.
Okay, I might disappear for a second though.
Okay.
As a warning, I'm just going to warn you now that I might disappear, but I will be back like within the next second. But
okay.
while I disappear, I expect all the answers to be coming up in the chat.
Okay, guys, we heard. Let's do this. Let's do this, guys. We can do this. We can do it. Now, in these kind of times, short is, you know, it's very useful because then you don't have to stop your work. You could continue with your work. But you will be back in a sec, guys. So I hope that it's going well. I see many of us are experiencing load shedding. We do in the dark. Leah also, Tebese also. And I think she's back, guys.
Guys, I'm losing patience with my connection today.
We can hear you though, clearly. I guess you just can't use your pen.
Okay, it's coming through now. It's just like, I think the connection just kicks me out every now and again, and it's very frustrating. Anyway, here we are. Okay, so what we have, don't panic if you're lost. Don't panic, we're all fine. Okay, if we're getting a common denominator of x, you could do a common denominator of x, or you could just multiply the top by x. Both ways are fine. I'm just trying to keep consistent language with what you may have been told in class. Okay, so what I would land up with here is negative x squared is equal to negative 6, and both of those would be over x. Now, when we have a fraction equation and it's over the same thing, we're allowed to drop the denominator. Okay, so it lands up dropped. Looks just like that. Nice and easy. Okay. Now, when we move that 6 over, what we land up with is we have negative, okay, have I taken something? Yeah, okay. So we're going to have, I'm going to move this over, and I'm going to have x squared minus 6 is equal to 0. Okay. Now, at this point, we're going to see that we're not going to be able to factorize, right? We don't have a difference of squares situation. Who panicked when they got to this point and they couldn't do difference of squares? Who panicked? Yeah. Okay. Who was like, I have done everything wrong. This is 100% incorrect. All normal. all a trap made and set for you by your maths teacher in order for you to panic so that you stop. Okay, but we don't stop because we're brain buffs. We just think, you know what? We can deal with this. We're going to say, all right, x squared is equal to 6. So all we're doing is we're saying x squared is equal to 6. We're going to say, therefore, x is equal to plus or minus the square root of 6. That's all we're going to do. We're going to keep it as a surd. We're going to keep it as plus or minus the square root of 6. We are not going to turn it into a decimal. And the reason we're not going to turn it into a decimal is because whenever we're dealing with functions, we want to keep things either as fractions or as it is like this. This is called surd form. Okay, and sometimes you can have an answer in surd form, and that's totally allowed. All right, so we know that our x values would be plus or minus root 6. Well done, Siamo. Good. Okay, then we have to get our y values. Now, the reason they could give us a yucky question like this is because our y values are actually just our negative version of our x values. Okay, so what that means is that when our x value is positive root 6, our y value will be negative root 6. So that will be b. And when our x value is negative root 6, then our y value would be positive root 6. And the reason I know that is because of this line up here, where it's telling that our y value is just the negative version of our x value. That's all that that's saying. And so because of that, they could give us an ugly question here where they didn't give us a nice answer, because we can just write it in surd form as a positive or a negative. So it was a yucky question only because we were dealing with surds. But if you guys got to this point over here, you were able to see that you were equating them, you were able to get it up, that's great. This is what you got wrong in your exam. Okay, well, I'm so glad that we landed up going through this. Because the thing is, like, often these questions come up and they will specifically give you a number that can't be factorized, and it will land up being a surd. And so I'm so glad that we got a chance to talk about it today. Let's talk about the next little part over here. So these two are quite similar. So if we don't land up getting through them both, it's okay. No, so this is not in Thursday's quiz. Thursday's quiz is a diagnostic quiz. So Thursday's quiz is based, it's going to be on some different work. It's not going to be on the work that we've necessarily covered in this holiday course. And it's just going to be to break you guys as a whole class up into 2 classes. So one class which would work at a slightly slower pace, and one class which would work at a slightly faster pace. You'll both have the same teacher, but one of you will have a class from 5 to 6, and one of you will have a class from 6 to 7. So your quiz on Thursday won't have anything to do with this. That's why I thought we could really kind of stretch it and push each other a little bit and get some nice brain work in. Okay, so let's have a look at B. B, determine DE if OC is equal to 3 units. Okay, so they're telling us that OC is 3 units, and they are wanting us to work out DE. They're wanting us to work out that little line over there. Okay, so let's try and break this up a little bit. First of all, every time you are told information in a question, you are going to need to use that information. So the first sentence where they told you that OC is equal to 3 units, how does that help me? How does it help me to tell me that OC is 3 units? What information are they telling me that's going to be useful? Think about C. Good, good, good. Our value for C, our X value for C is going to be 3. Exactly, we have an X value, okay? And this line over here is parallel to our Y-axis, which means that all of these X values are going to be 3. We don't know what their Y values are right now, but we know all of their X values are going to be 3. Okay. We now need to know what that distance of DE is. So do you agree that if we find our Y value for D, and we find our Y value for E, we'll be able to find the distance of DE. It's not so bad, right? So it looked like a really horrible question, but it's not so bad. So our equations that we're going to be dealing with is y is equal to negative 6 over x and y is equal to negative x. Those are the two that you're going to be working with. And I want you to find these y values for me. So I want you to look at which line they are lying on. And I want you to find that distance. Yeah, don't panic, Savolga. It will all be very clear and it will be on Thursday. So don't stress. Okay, so I'm wanting you to find my two y values here, and then I want you to tell me what my distance of DE is. Okay, so we've got our first value. Keep them coming, guys, and if you disagree, write your different answers there. I'm very curious to see what you get. Yeah, sure, I can absolutely go up. Okay, so we're looking for our coordinates of D and our coordinates of E. So E should be nice and easy to get. And D shouldn't be too tricky. Hello.
Okay, yeah, I feel like I'm a little confused. I feel like I'm a little
Okay.
lost. Okay, so what's highlighted over there in blue, we were supposed to go and find the values of, not so?
So in these ones that are highlighted in blue, you're going to substitute y is equal to 3 into both of them.
Okay. So while doing that, I got an a minus 2, and then the other one was a is equals to minus 2, and then the other one was a is equals to minus 3.
Well,
But
why,
then
wait, hold on. Why do you have a's involved? Where are a's?
I just substituted what is there on the board. Exactly. I just substituted the 3 inside the x.
Okay, but
Yeah.
then where's your a coming from?
So wait. Okay. So what I am seeing right now, what my head is telling me right now is that,
Yep.
okay, so it's a is equals to minus 6 on x. And the other one is a is equals to minus x. So what I just did was simply substitute the whole thing. So I just said a is equals to minus 6 on 3. Instead of saying x, I just said on 3. And then I said on the other one, a is equals to minus 3. That's how I got it.
Yes. No, that's right. Just don't use a. The only reason I'm saying don't use a is because it's a different variable in this graph.
Different variable in the graph, meaning.
So so over here, do you see how there's a point A over there, which is the point of intersection of that parabola and the straight line?
Okay, yeah.
So because A is already being used somewhere, we can't use A where we don't want to use it. Okay, so you're absolutely right. You are going to substitute in that x value there. So over here, you're going to say y is equal to negative 6 over 3. And here you would say y is equal to negative 3. Okay, so y would be equal to negative 2, and then y would be equal to negative 3. So what you were saying is beautiful. It's just don't have an A, have y.
Oh, no, I mean, sorry, it's actually y. English,
Okay.
it's y.
Oh,
Y,
okay,
English.
got you. Okay, no worries. Then we're all on the same page, and I'm very happy with what you've done there.
Okay, no problem, no problem. Okay, so
Okay.
then from here on out, what is my next step supposed to be? Because I feel like I'm
Okay,
supposed
so
to
what
be
yeah, no, that's good. So what you figured out here is you've said that the coordinates for D then are 3 and -2, and the coordinates for E would be 3 and -3. Okay, so that means that this Y value here is -3 and this Y value here is -2. So the question was, what is the length of DE? So what's the length of DE?
I would say 1. I'm guessing.
Yes,
I'm guessing.
no, that's right. You're not guessing. You're being smart because the difference between -2 and -3 is 1 unit. So it's 1. That's it.
Okay. It's fine. It's fine.
Yes.
I'm on the right. Thank you.
Progress. Yes. Nice job. Okay. Good. And our time has like flown by from us, which is just ridiculous. Yes, Bokomoso is doing Vuskada. I keep on forgetting. I need to remember. Okay, so guys, just if you weren't understanding what I was saying over there, all we're doing is we are substituting in that x is equal to 3. We knew that because of what we were told about OC being 3 units. We substituted into our 2 points. We got our 2 different y values, and then the difference between -2 and -3 would be 1. So then the distance between D and E would be 1 unit. Okay. This last question here, so this one over here, determine FG, is going to take us longer than the time we have left. So on Thursday, we're going to start with that horrific question from Okukwale. Thank you for that again. And then we are going to do this question. So we're going to do C. If you have other questions from your exams, remember you can always bring them in. You also, if you're too embarrassed to speak, you can write them in the chat. That's also fine. So we'll start with our lesson with that, and then we're going to just do some trig on Thursday before your quiz. Okay. All right. Pace poll. Let us know how today went. If you are new, I can completely understand how you're overwhelmed, so please don't panic. And I will see all you lovely little lasses on Thursday. I hope you have